Hi, and welcome to a quick look at equivalent fractions. Okay, so it's fairly basic stuff. Just make sure you're okay with the basics first before we try anything heavy. So first, reading a basic fraction. Look here, I've got 2 bars shaded in and 5 bars altogether. So this fraction over here is 2/5. However, what I can do, I can chop this fraction in half down the middle here. Still the same fraction, but if I do the same thing here and work out what fraction it is, I'm going to get a different answer. So looking at it now, I've got 1, 2, 3, 4 boxes shaded in and a total of 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Same fraction, 2 different numbers, and these things are called equivalent fractions. Okay, they're basically 2 fractions that mean the same thing but have different numbers. Okay, that's the basis of how it works. As a better definition, equivalent fractions are basically different ways of writing the same fraction. So looking here, all these fractions over here is half a circle shaded in. Depending on how many times we cut up that circle, we can write basically as many different ways as we want to. Also quickly notice for all these fractions, this bottom number is always double the top number. So for example, you could have 100 over 200, and that is still equivalent to a half, because 100 is half of 200. Okay, let's see some kind of questions that are likely to throw at you. First things first, look at part A. So you have to write down equivalent fractions to something like 3/5 in this example. If you want equivalent fractions in a row, there is a slight shortcut. So the first one is 3/5. If I want to generate another 1, 2, 3, 4 here, all I need to do is for the numerator, just run across the 3 times tables. So the first number is 3, so I'm running across the 3 times tables, and that is 3, 6, 9, 12, 15. And then we're going to do the exact same thing for the denominator, the bottom number. We're going to run across the 5 times tables. So it starts at 5, then it's 10, 15, 20, 25. Go these for a second. And all these fractions are equivalent to 3/5. And we can keep going on. The next one will be the 6, so it would be 18, add another 3, and add another 5 will be 30. We can keep going for as long as we want to. Okay? Next kind of question you tend to see is you're given a list of fractions, and you'll be told which are equivalent to some fraction. In this case, I've used a third. Probably the best place to start is kind of the same we did over here. I'm going to write down a third, and I'm going to work out some equivalent fractions. So on the top, I'm going to run across the 1 times tables, which just goes 1, 2, 3, 4, and 5. And along the bottom, I'm going to run across the 3 times tables. So it'll be 3, 6, 9, 12, 15. I'm going to use this as a quick guide to working this out. So first, 2, 6, that is on my list, so that is equivalent to a third. 3/10 is not on my list, and I've also got 3/9. That means if there's a 3 at the top, there must be a 9 at the bottom. So because there's a 10 here, that means this is not equivalent to a third. 10/30 is not on my list. I'll come back to that in a second. Moving on, 5/18, we don't have that either, but we do have 5/15. So by the same rule, if 5 is on top, then 15 must be on the bottom, which means this is wrong. And I've got 4/12 at the end, which is on my list, so that is allowed. This takes us to 10/30th. There are a couple of options. We could keep on going. We could keep on going, adding 6, 7, 8, 9, and 10, and then the bottom number is 30. However, we should be able to see that 10/30ths is just both these numbers times by 10. So it is equivalent. So whenever you times both these numbers, 1 and 3, by the same number, that will always be an equivalent fraction. And that's actually exactly what we've done here. Here I've times 1 and 3 by 2. Here I've times 1 and 3 by 3, and so on and so forth. Okay, moving on. The next type of question I'd like you to see is a fill in the missing numbers question. We know 2/5 will equal something over 10. We want to work out what this something's going to be. The way we do it is we need to work out what we have multiplied by here. So in essence, how many 5s go into 10? In this case it's 2, 2 5s are 10. So we're going to have to times the whole fraction by 2. So 5 times 2 is 10, and we also do 2 times 2, which gives us 4. Okay, trying the other one. Same idea. We have two numbers here, so we look at these, and we're going to work out what have I times 3 by to get to 33, or how many 3's go into 33. Either way is 11. 3 times 11 is 33. Remember, if you times anything by 11, let's say 9, it will just be the same number doubled. So 9 times 11 is 99. So quick pattern to remember. Doing the same with 5. 5 times 11 is going to be 2 5s, or 55. And that's it. They're the three type of questions you're going to see to do with equivalent fractions. Okay, you have some questions here to practice. So questions 1 and 2, and 3 and 4, all based on the three questions I just went through a minute ago. Okay, feel free to pause and give those a go. I'm going to move on a couple of seconds and just give the answers to the questions in black. Okay, answer questions in black. I won't talk through these. Hopefully it's fairly self-explanatory. For question 2, these were the only two, the other 4 weren't. And again, feel free to pause if you want to mark a bit more carefully. Okay, moving on. Last thing to do with equivalent fractions is simplifying fractions. So, a fraction is simplified when you can't make it any smaller. So, for example, if I had this fraction here, if I had this fraction 3 over 6, we've just seen that is also equivalent to all these fractions. If you want the simplified fraction, that will be the fraction which has the smallest numbers. So in this case, for all these fractions here, the simplified fraction is 1/2. Okay, so it's a fairly straightforward concept. Let's have a quick look at how we're going to do that. When you've got a fraction, you want to see what numbers divide by the top and the bottom. So for example, for this part A here, both these numbers are even, so they both divide by 2. So let's make it really clear what I've done here. I've divided everything by 2. 2 divided by 2 is 1, and 8 divided by 2 is 4. So 2/8 simplified is 1/4. Sometimes you can simplify this again, but in this case nothing goes into 1 and 4. If you ever have a 1 anywhere, that means that fraction is always fully simplified, as it is, it's as simple as it can possibly be. Okay, next one is B. This one, they're not even, 5's not even, so we can't divide by 2. However, any number that ends in either a 5 or a 0, you can divide by 5. So I can divide top and bottom of this equation by 5. If I do that, that's going to be equal to 5 divided by 5 is going to be 1, and 30 divided by 5, or how many 5's in 30, is 6. And again, we've got a 1, which means this fraction is fully simplified. Part C, we've got 12 over 15. Doesn't divide by 2 because this is an even. It doesn't divide by 5 because this doesn't end by a 5 or a 0. The next test you tend to want to make is does it divide by 3? And in this case it does. So same as before, we're going to divide both top and bottom by 3. So 12 divided by 3, that gives us 4. 15 divided by 3 gives us 5. Okay. As always, we want to check, can we simplify this further? Can we divide by anything else? In this case we can't. Another quick trick, if you have two numbers that are next to each other, you can never simplify any more. So 4/5 or 11/12 or 17/18. Anything where these two numbers are 1 apart, you can never simplify any more. Okay. Last example is 12/18. So it starts off fairly simple. Both these numbers are even. That should always be your first check. If they're both even, that means we can divide them both by 2. So if we halve 12, that gives us 6. If we halve 18, that gives us 9. And again, we want to check, can we simplify this any further? It doesn't divide by 2 anymore, doesn't divide by 5, but it does divide by 3. So I'm going to do one more step to make sure it's fully simplified. I can also divide both of these by 3. 3's into 6 is 2, and 3's into 9 is 3. Again, these numbers are 1 apart, which means it cannot be simplified any further. Okay, hope that was clear for you. we know the drill. Here's some questions to try. Feel free to pause it and give it a go. And in a couple of seconds, I'll give the answers to the questions in black. Okay, going for the answers. These questions over here. Quick aside for question 2. First things first, you can divide them both by 2. If you do that, you will first get 2/4, and then you want to divide it by 2 again to get a half. Question 3 is straightforward, divide them both by 5. Question 4, first you want to divide both the numbers by 5. That will give you 3/9, and then down to here, you can divide them by 3. So always check, can you divide again? Can you simplify it further? Okay, all we're doing today, thanks for listening, and I hope that made sense to you.